Hello, Tim Morris from Cincinnati State. Today we're going to talk about pressure compensated pumps, variable displacement pressure compensated pumps. So it's a big long word. Variable displacement means that we can change the output. The displacement is output. We can put a lot of fluid out or we can put a little bit. That's variable displacement. The pressure compensated, that's how the pump works. So we can change our output by monitoring the pressure and compensating for the pressure in the hydraulic system. So let's take a look at how this works. If you can imagine a syringe, imagine that you can suck in fluid, you can pull in fluid, suck it in, and you squeeze it out under pressure. Imagine a whole bunch of syringes in a pump, and that's what we're going to be looking at here. This is figure 1229 out of the FAA-H-8083, and let's take a close look at this. We've got a green input and a red output. And up here we have a piston. And you can see that we're showing this. In fact, I got a couple cursors going. And there's an impeller. And fluid goes in here. And the red is under pressure. That's pressurized fluid that we're looking at. We've got a piston, the green, and then the red is squirting it out. That's pressurized. We've got a shaft that we're a coupling shaft that's connected to the turbine engine on the airplane, most likely. And that's going to spin with the engine. And then we've got a relief valve in here. We've got a compensator valve in here we're going to look at. And then we have an actuating piston here. And we'll see a yoke. A yoke will change the output. But we're going to get into that here in just a second. Compensator valve here is what makes this all work. Here's another cutaway. This is another figure, and we're going to look at the pistons. This is the same pump. We've got this pump yoke, and it will swivel, and that will change our output. That's how it's variable displacement. Okay, and in just a second we're going to get on to the animation of this, and you're going to see how all this works. So this is from mechanicisms.co, courtesy of YouTube, and we're going to see this animation here. This is the pump here, and these are the pistons. We're going to see anything that is blue is something that is sucking in fluid. That's the input, and the red is the output. And this is the swash plate, this black angle plate. That is going to give us changes. How much are we going to get out? That's going to vary the output. There's a handle here, and they're going to move this handle, and they're just going to show high output and low output. Moving this swash plate is what will change our output. On this right-hand side, if you can imagine a pump here, this blue is the inlet, and the red is the output. So we're looking at it cut away from the side and from the end here. Here's our input. We're going to suck fluid in. We're looking at the pump like this. Over on the other, we're looking at it the other way. Red is output. Okay. So here's our pistons, and we're going to start this animation up here. We're going to show these pistons are like the syringes, if you will. So we're going to start the animation here. Okay, this shows all the pistons pumping here. And we're going to take away a whole bunch of them. Okay, imagine one syringe. Red is squeezing it out. Blue, it's sucking it in here. Now it squeezes it out. And if we move the swash plate, see that lever moving? This output is hardly any. Now we're increasing output. So the more the angle is on this plate, the more our output is. Now we have two syringes. Imagine that we have two. One's sucking in while the other one's squeezing out. Now we're going to increase our output. And what's increasing is how much fluid we're sucking into each syringe. It's actually a piston. Now here's all our syringes put together. So this pump has a whole bunch of pistons, and the swash plate will vary the output for the portion of flight. So if you can imagine taking off and you put the landing gear up and the flaps up, you need a lot of fluid. So this right here is the high output. The swash plate is at a high angle. And That's our high output. When we're in cruise flight, we don't need as much fluid. So the yoke will be what changes the output. If it's slanted like this, it's a maximum pumping angle you can see here. If it's straight up like the dotted line, we're not putting out hardly any fluid. That's the minimum output. Maximum pumping angle here, and here's the cutaway. What's doing the work is the fluids coming in, getting sucked into these pistons, being squeezed out the red, and we have a compensator valve down here. This red is our output. We have a compensator valve, and that compensator valve is going to vary the angle of this yoke. And the yoke is what will change the angle of the pistons. So that compensator is going to change the angle of this. And this cutaway is going to show the pump yoke. This is our best view of this. Compensator pushes the pump yoke and changes the pistons, how much fluid we can suck into the pistons. So that is the variable displacement portion of it. The sensing of the pressure is what makes it all work. When the pressure drops, we can get more fluid because that yoke angle will change, and the pistons will now, that yoke angle will change, and we can get more output from the pump. That's the variable displacement pressure compensated pump. Thanks for watching.